Hey everyone, this is Mr. Barthold, and basically this video is to go over the answers for the review for the test that I gave out today and yesterday during class. So we start with the first question, which we have a circuit here. We have a battery, 9-volt battery, connected to a light bulb which is of resistance 20 ohms. And we're trying to find the current. So hopefully you remember that current is related to resistance. So the more resistance in a circuit, the harder it is for current to flow, so the less current there is. And that is something that is related in Ohm's law, which says that the current is proportional to voltage, but inversely proportional to resistance. So you increase the resistance, current decreases. In this case, we have a 9-volt battery and 20 ohms of resistance, and that should give us 0.45 amps of current. First problem. For the second one, we need to find power, and electrical power rather, is given by current times voltage, so P equals I times V. And so in this case, we have a current which we just found was 0.45 amps, and we are multiplying that by 9 volts. So we should get 45, 13, and 17. So excuse me, that's horrible math. Oh man, I'm embarrassed. What was that? 45, 4, 9 times 4 is 36, so 4.05 watts. So about 4 watts of power. So that's 4.05. And so remember, power is the rate at which energy is consumed. So if we're using 4 watts of power, that means we're using 4 joules every second. Every second that this light bulb is on, 4 joules is being used. So the question is, if the light bulb is on for 1 hour, how much energy is used? So if we know that 4 joules is being used every second, if we multiply it by the number of seconds, then we will get the total number of the total amount of energy that the light bulb will use up. So in this case, our power is 4.05 watts, and our time, talking about 1 hour here, so we need that in seconds. Where a watt is a joule per second, so this time actually needs to be in seconds. So we have 1 hour, we can do a little dimensional analysis. So 1 hour is 60 minutes, and 1 minute is 60 seconds, so we get, cancel, 60 seconds, 60 times 60 is 3,600 seconds. So 4.05 watts times 3,600 seconds. And after that last problem, I think I should move over to a calculator, especially we're getting big. I don't want to make another graph on something. So should get 14,580 joules. 14,580 joules of energy. Number 2. Got a different circuit now. Instead of just 1 light bulb, we have 3. Or technically these are resistors. They could be light bulbs, circles around them. So total resistance of this circuit. What do we got? We have 3 resistors in series. So we know they're in series because there's only one path for them to go. They leave the battery, go through the first resistor, there's nowhere else to go but to go through the second resistor and the third resistor. One loop, one path, series circuit. And so the total resistance, if it has to go first through 1 ohm, then through 2 ohms, then through 2 more ohms, then the total resistance is just 2 plus 2 plus 1. And so I believe this was in our notes that the total resistance for a series circuit, you just add them up. So 1 plus 2 plus 3 which is 1 ohm, 2 ohms, and 2 ohms for a total of 5 ohms. So total resistance is 5 ohms. So how much current flows through the circuit? Well, we know we have 20 volts, our battery, and the total resistance that this experiences is 5 ohms. So again, we can use Ohm's law, V divided by R, and there's a total of 20 volts and a total of 5 ohms, so the total current is going to be the division, which is 4 amps. And power, similarly, I times V, current 4 amps, voltage 20 volts, is going to consume 80 watts of power. Last one on this first page, what is the total equivalent resistance of this circuit? To the right, and this is a little bit different. This is not in series. If you notice, one way we can go through this battery, we can go through this light bulb, and hey look, we're done, we're back to the battery. There is another way we could go through this 20 ohm and back to the battery, or through this 5 ohm and back to the battery. So there's 3 different paths, not just one. There's 3 different ones, and this is called a parallel circuit. So the total resistance is not just 10 plus 20 plus 5 anymore, because one electron may only go through this 10 ohm, and it doesn't have to go through the 20 and the 5 like this one. So there's different paths. So to find this total resistance, we have to add the inverses. If we remember, it'll look something kind of like this. I'm gonna write it up here. I'm gonna need this space up here. So the total resistance in parallel is 1 over the resistance plus 1 over the second one, 1 over the third one. If we add more, 1 over the fourth one, 1 over the fifth one, etc., etc. And this is not the answer, but the step that most students miss is they forget to take the reciprocal or the inverse of the final answer. All right. So we've got to go ahead and add these up. We have 1 over 10, 1 over 20, 1 over 5. So let's check it out. Common denominator, this is not, you do not go this is not 3 over 10, 12, 35, right? No, not 3 over 35. What do we got? Common denominator is 20. So 20, 10 times 2 is equal to 20, so 2 over 20. This one's already over 20, that's nice. And then when we got 20 here, 5 times 4 equals 20. So 2, 4, and 1 makes 7 over 20. And again, last step, this is not the answer. We have to take the inverse of that, which just means flip this fraction around. So we get 20 over 7 ohms of resistance. 20 over 7 ohms of resistance. And that should be about 2.85, 2 6/7. So 2.85, I believe. 2.86. If you have a decimal answer. And the last one, a little tricky. You have to actually combine. So basically, we're trying to find energy again, and we know that energy is power times time. But we don't know power. We know that power is current times voltage. So I'm going to write this over here. Power is current times voltage. But hold on, we don't know current yet either. Remember, current is voltage divided by resistance. So basically, I'm making you do it all over again, except all in one step. Nice like that. So what do we got? First, we find the current, 120 volts divided by, I guess we could say 20/7 ohms. So that should be 7. So I believe that's 42 actually. 20 over 7. So let's just double check that. It is 42. So 42 amps of current, which is actually quite a bit of amps. That's going to be drawing lots of juice there. So now our power, we know we have 42 amps and 120 volts. So that comes out to 5,040 watts. And finally, energy is power times time. So 5,040 watts multiplied the time, which is 30 minutes. 30 minutes times 60 seconds per minute is 1,800 seconds. So we get a total energy of a very large number. So 9.072, if you'd like, times 10 to the 6th joules. So 9.072 times 10 to the 6th joules of energy was consumed. Alright, so sometimes you have to work backwards like that. So you know you have to find energy, but you might not know power. So okay, we can find power, but you don't know, okay, we can find current first. So you kind of have to go back a little bit to redo what you need to do. Alright, so there's the back of this page. I'm going to post this on the next video because I'm approaching my time limit here. So tune in.